So we're going to turn our focus to geometric series, which is the sum of all the terms in a geometric sequence. And we talk about Gauss again. He again created this formula to find the sum of any geometric series. And he tried the same concept as he used before of switching the order of the first term and the last term and seeing if all the sums were constant, and it didn't work. So then what he noticed is he said, well, if I was to take and multiply my entire series by the ratio itself, what would I get? And he found out multiplying that ratio by the first term actually got me the second term. If I multiplied the second term by the ratio, I ended up getting the third term. And he found out this continued to happen throughout the entire series. And when he got to his last term, the ratio times that last term in the series, remember we take and add the powers of common bases. This got me the first term times the ratio to the n. And then he said, well, look at all this stuff I have lining up under each other. What if I was to take and subtract the bottom term from the top term? What's that going to get me? Well, it gets me the series minus the ratio times the series is equal to the first term. All these middle terms went minus the first term times the ratio to the n power. And then he said, well, we've got some common terms, so let's factor those out. And we want to try to find the sum of the series. So let's isolate that, and we get the first term times 1 minus that ratio to the n power over 1 minus the ratio. And that ended up being his general formula for the sum of a geometric series. Let's clean it up a little bit. And here it is. Obviously, a sub 1 is your first term. R is your ratio. N is the subscript. Or in this case, the number of terms. We've already talked about R, and S sub n is the sum of n terms. Now let's do a couple of problems. So using this formula again, the sum of, it turns out in this case, 12 terms is equal to that first term times 1 minus the ratio to the nth power over 1 minus r. Let's see what we've got here. So like I said, we have the n value. We actually have the first term, it's 4. 1 minus that ratio, which we're given is negative 3. We have the number of terms, 12, over 1 minus that ratio. So this turns into a plug and chug problem and just becomes a calculator. And after plugging everything in, we get about 531,442. In our next example, once again, I will write the formula up since it's a little bit new. The sum of n terms is equal to the first term times 1 minus the ratio to the nth power over 1 minus the ratio. And in this case, it looks like we're given that first term, so 48. We're given the value of the nth term, which is nowhere in this formula. And we're also given the ratio of a half. We don't have the value of n. Once again, we have that half. So we're going to have to find the value of n. Well, I know this is geometric. I know it's my ratio. And I can use my explicit formula of a sub n equals a1 times r to the n minus 1 for a geometric sequence to find the value of n. So we'll start with a 48. We'll say my ratio is a half. It's raised to the n minus 1 power. And that's supposed to equal my nth term of 3. Divide, I get 1/16 is equal to a half raised to the n minus 1 power. Common bases of a half. This is a half to the 4th. This is a half to the n minus 1. Whoops. Therefore, 4 is going to equal n minus 1, and n would equal 5 in this case. So now we have everything we need for our sum. I have 48 times the quantity of 1 minus a half raised to the 5th power over, I'm just going to call it a half since I can do that math in my head. And again, it becomes a calculator problem. And in the end, we end up with 93. So moving to the next problem, we want to find the sum of the first 7 terms in the series, but we're given the second term and the 5th term, which means we're going to need to find the first term to get this problem done. So let's do that. If I know the second term is 36 and I know the 5th term is 972, I'm going to use that trick I've used before. I'm going to let a second term go to the first term, and the 5th term would then move 1 term down and act like the 4th term. So in using my explicit formula, I could say that 972, which is acting like the 4th term, is equal to the first term, which is like negative 36 in this case, times the ratio. And in this case, we have 4 terms, so I would say 4 minus 1 power. And that's going to give us our ratio. So I take and divide 972 by 36. I get 27, but that's negative, and that's going to be equivalent to my ratio. And in this case, we said n was 4, so that's to the 3rd term, or 3rd power. So r then is equal to negative 3, since the cube root of negative 27 is negative 3. Now that I have my ratio, I can find my first term, and if I'm multiplying by negative 3 to get to negative 36, therefore my first term is going to be 12. So now I'm going to use my sum. The sum of the first 7 terms is equal to the first term, 12, times 1 minus my ratio, and we've just found my ratio is negative 3, raised to the n, that's 7 in this case, all over 1 minus my ratio of negative 3. And again, it turns itself into a calculator problem. And after plugging it in the calculator, we get 6564. All right, now in this case, we're actually given the sum of the first 6 terms and a ratio, and we're looking for the 4th term. Well, our general formula of S sub n equals a1 times 1 minus r to the n over 1 minus r doesn't give us individual terms other than the first term. So we're going to find that first term, use our ratio to calculate the 4th term. So let's start with the sum of the 6 terms of 315. It's going to equal whatever my first term is times 1 minus the ratio of a half is given to us. We know we have 6 terms over 1 minus that ratio of a half. So in doing some calculations, I get the first term times 1 minus a half to the 6th power is 1/64 over a half. So, going to simplify just a little bit. Let's call this 2a sub 1 times 63 over 64 would equal 315. And I will reduce that a little bit. So this is 63 over 32 a sub 1 is equal to 315. So the first term is then equivalent to 160. As I said before, we're now going to use the nth term is equal to the first term times the ratio to the n minus 1, and say that, well, we're looking for the fourth term. That's going to equal my first term of 160 times my ratio of a half raised to the 4 minus 1 power. Or in this case, 160 times 1/8, which gives us a fourth term of 20. And that's all we've got for you today. We'll see you tomorrow.